Hello everyone, welcome to EECS 216 Labs. This will be an overview of Lab 5. Hopefully at this point you're all safe and healthy at home. This lab is purely virtual, so as long as you have access to a laptop, you should be able to do it without problem. If you don't have MATLAB installed on your personal machine, you can virtually sign into a Kane machine using a VPN and do the same thing remotely. Alright, so there are only a couple things you need to know to complete this lab. We'll be using a tool called Simulink, and to access it, simply type Simulink into the MATLAB command interface. Alright, once that loads, we'll choose a blank model. And from here we can get started importing our components, making connections, and starting the simulation. So for the first section, you'll need 4 components. The first is a step input. And to access the component, simply double click and enter the name of the component you want. So in this case, a step. Now, the second component you'll need is a controller. In this lab, we'll be using PID control. So do the same thing for that. You will also need a transfer function block to encompass the car mechanics. Finally, you will need a scope to view the output waveform. Now, connecting each of these components is very simple. Start on one arrow and drag it to the next. Alright, so the next step is to insert the appropriate values for the simulation we're running. We'll use our set speed as 40 meters per second. PID I won't change now, I'll leave that for you in the lab. As for the transfer function, it's in bracket form. So enter 1300 for the mass and 50 for the damping coefficient. The numerator stays as 1. And from there, open up your scope, press play, and you are simulating. Alright, a couple things to keep in mind. If you want to change your time axis, go up to the top right, change that to 50 is a good value, and run the simulation again. And you have a larger time basis. Alright, the 2 more components you'll need is a sum block. In which you'll replace the existing wire and add it in between. You have to change the list of signs so you have a reverse feedback system, and simply run a wire to the output. Alright, so it's as simple as that. You can run your simulation again and see the changing output. Alright, so those are the basics for Lab 5. In the last portion, you'll be working with a slightly more complicated model in which we will provide the SLX for your convenience.